Welcome back, everyone. In this lecture, we're going to be discussing comparison plots. And in part 1, we'll focus on just understanding the plots and when to use them. And then in part 2, we'll code them out with Seaborn. Comparison plots are essentially two-dimensional versions of all the plots we've learned about so far. And in some cases, we've actually already seen the separate plot types, but they're just joined together and combined. The two main plot types we're going to be discussing are the joint plot within Seaborn, as well as the pair plot. So let's start with the joint plot. What we can do with the joint plot is we can map histograms to each feature along with a scatter plot to clarify the distributions within each of those features in the scatter plot. What's also nice about the joint plot is you can adjust the scatter plot to be a hexagonal plot or hex plot or a two-dimensional KDE plot. Let's work through some examples here. So this is the joint plot, and essentially the basic joint plot is a scatter plot of two continuous features that adds in histograms. So this is just what a basic joint plot call looks like. We can see the relationship between the math score and the reading score, and it makes sense that the higher your math score, the more likely your reading score is also going to be higher. So we already know about the scatter plot. The joint plot simply adds on those histograms. Now what's important to note is that with the joint plot, you have different options of how to display that relationship inside of the square. You can also use hexagons. So what's the difference between the points and the hexagons? Well, the hexagons are going to be dark the more points that fall into their area, and you can actually adjust the area of those hexagons. And this is really useful when you have many points that overlap. So if I go back to view all these dots, it's actually not super clear how many points we have between, let's say, scores of 60 and 80 in both math and reading. We could adjust the alpha value, as we've seen before in this scatter plot, but sometimes using these hexagons is a little more useful. It actually narrows down the band ranges and then clarifies where we see the relationships. Something else to note is that it doesn't have to be histograms. You can also just say KDEs. And notice now we get to see the KDE per feature. So we get to see the KDE of the reading score as well as the KDE of the math score. And then essentially a two-dimensional KDE relationship shows a shaded distribution between both KDEs of the math score and the reading score. Keep in mind, this sort of two-dimensional KDE plot is not super common for certain fields, but it is really common in certain scientific fields. So again, you should know your audience before jumping straight to a really nice looking two-dimensional KDE plot and make sure that they're familiar with the plot type. Now let's talk about the pair plot. The pair plot is super useful, and this one is actually super common to see throughout visual exploration and exploratory data analysis of data sets within machine learning. And essentially, all the pair plot is just a very quick way to compare all the numerical columns in a data frame. What it does is it automatically creates a histogram for each column so you can see the distribution of all the numerical features, and then it also creates a scatter plot comparison between all possible combinations of those numerical columns. So something to keep in mind is that this pair plot operation is only going to operate on numerical columns. Now, a quick warning, the pair plot command itself within Seaborn can actually be CPU and RAM intensive, especially for large data frames with many columns. So it's a good idea to first filter down to only the columns that you're interested in before calling pair plot on the full data frame. So go ahead and use Pandas, filter out certain columns, and then pass those columns as kind of a mini or sub data frame into pair plot. So let's actually explore what the pair plot looks like. By default, the pair plot is going to look like this. So notice here, I went ahead and filtered down to just the score columns from that student performance data set. So I have the math score, the reading score, and the writing score. Along the diagonal, we can see that this shows you what the actual histogram distribution is for each of those individual score types. Then we can see the scatter plots for all the possible combinations of these numerical columns. I can see reading score versus math score, writing score versus math score, and then writing score versus reading score. Now, because of the way this is set out, you'll notice that it's essentially mirrored across the diagonal because the math score versus reading score is going to be the same as reading score versus math score. Something else to note here is you have the option to add in a hue parameter, which is really nice, especially when you're dealing with a machine learning data set that uses something like labels for various classes or categories. So here what we did is we're showing the same information, but now we've colored it based off the gender categorical parameter. So again, just showing a lot more information here. And if you want, you can also change the diagonal to be a KDE instead of a histogram. And recall that we mentioned that if you notice, one side of the diagonal is essentially repeated information. So you often see people with an parameter call within the pair plot to just go ahead and get rid of that top diagonal to not show duplicate information. Okay, so let's go ahead and code out these comparison plots in the next lecture with Seaborn. I'll see you there.